So today with algebra, we're going to be taking a look at exponential operations and exponential functions. We've already gone over the product of power rule, which is if you take a base multiplied by the same base, but they're raised to different powers. So a base raised to a power multiplied by the same base raised to another power is going to equal that same base that has appeared both times on this side raised to the a plus b power. So you're just taking the exponent from the first one, adding it to the exponent of the second one, and that'll give you your answer. But today we're going to be looking at the quotient of power rule. With this one, it's the inverse operation of the product of power rule, the same way that that division is the inverse operation of multiplication. So you have a base raised to a power divided by that same base raised to a different power. You're going to carry the power over here, and all you're doing is top minus bottom. Top minus bottom. That's all you're worried about. You're just taking the top and subtracting the bottom. Whatever the numbers are, top minus bottom. So let's take a look and see it in practice. See, the thing is, I know how this is going to end up. Because we've done a couple problems like this, I know how it's going to end up. It's going to be another huge calculation. I can't simplify the answer, but you know what? It's fine. It's okay. We're here to review the quotient of power rule, so that's what we're going to do. So, when you're looking at the quotient of power rule, you're looking at a base raised to a power divided by that same base raised to a power. So if I treat the number 8 as the base, which it is, 8 is the base in this case. The base is simply whatever number you have or whatever variable you have, whatever decimal, whatever fraction, whatever expression. The base is the number that's raised to the power. So whatever the big chunk is, the power, if it has an exponential power to it, the base is the bottom part. So 8, just because it's a number, it can be a base too. So we have a base raised to a power divided by the same base raised to another power. What that means is carry over the base, and it's top minus bottom. Which in this case is 8 to the third power. Now, like I mentioned, I saw this and I immediately knew what was going to happen. But what we're going to do is we're going to walk through the simplification rules again. Well, anyway, we're going to walk through them anyway, and I'm going to explain to you why I'm not going to simplify this out anymore. First of all, do we have any negative exponents? No, we don't. Does the base variable only appear once? Well, the problem is we don't have any variables, so the rule doesn't apply, so we're good to go. Are there any numbers raised to powers? Unfortunately, yes. So this is 8 times 8 times 8, which I don't want to do in my head, but if you have this, you have to resolve it. If this were attached to a bunch of variables, like a bunch of x's, a bunch of y's, and you're canceling things out and you're using different products of power and you end up leaving this behind, you have to resolve it. Because it's a number raised to a power, that means that you can solve for it. So 8 to the third power is going to equal some number. So you bust out your calculator, raise 8 to the third power, and that will be your final simplified answer for this question.